All right, today we're going to move into lesson 2.1. It's two-dimensional representations of three-dimensional figures. We're going to be asked to, look at some different three-dimensional drawings and either identify, what they're made up of in terms of how many blocks and what that would look like from different angles, and then also work on some nets of some three-dimensional shapes and use those nets to help us with some surface area questions. Okay, so first of all, this first example is more of a perspective and being able to look at a shape and kind of think of it from different angles. So it says the figure below shows a solid made from stacks of cubes. The answer box shows the same solid viewed from above. And for each stack, write the number of cubes in the stack. So, we're supposed to fill this out down here by looking at this. So the first thing we do is, if you look at this, if you look down this first stack, you can see there's three cubes that make this first stack. And we got to start somewhere to give ourselves some dimension. All right. And then based on the fact that there's three here, if you go the rest of the way around the shape, this would have three stacks, and then these two back here would have two, another stack of three, and then stacks of one. All right, now we need to take this perspective and the number in the stacks and put it into this chart. And if we do that, this is the back left right here. That's three. This is the back middle, two, back right, two, front left, one, front middle, front right. Okay, so it's just some depth perception stuff, and it's some, understanding the angle that you're looking at it from, and, being not, being able to project these different stacks and how many cubes there are. All right. Another way of doing the same kind of problem is say, all right, let's given this drawing here, given this shape, draw the front and the right views of the solid. So they're saying this is the front and this is the right. All right. So as you look at it from, let's say, the front, you have to think about standing here and looking at it. What surfaces would you see? Well, if you looked at it from the front, okay, again, this is the front, you would see these cubes, one, two, three on the left, four, five, six stacked here, and then seven and eight kind of stacked over there. So as you look at it from the front, this would be what you would see if you looked at it dead on from the front. Three, three, two. All right. Now, if we look at it from the right side, okay, then as from the right side, you got this stack of two, and then you got three, four, five here. So that's another stack of three. And then six, seven, eight is stacked here. So if you looked at it dead on from the right, it would look like this. All right. And the answer here is, just redraw this. So from the front, we're going to look like this. And from the right, we're going to look like this. Now it's just perspective and understanding, how the blocks are going to look as you look dead on from one direction or the other. The next thing we're going to move into are the idea of nets and nets of solids. So when we talk about nets, what we're really saying is to take a three-dimensional shape, and if you were to cut it along all of its edges and unfold it, what would it look like once it's unfolded? All right, so we can do that for any of these. So down here it's saying, all right, so for each net below, select the solid to which it would fold up to. So if we look at our first example, if we were to fold on these edges and fold it up, this shape is going to make this rectangular prism. Okay, for number two, if we folded the triangles up and then folded these up, okay, this is going to make this triangular prism A. Number three, we've talked about this in class. If I fold the circles up and I wrap this rectangle around, this shape makes a cylinder. And none of these up here are cylinders, so that would be our none answer. And for number four, if you can imagine kind of wrapping this curve along this circle, this edge would then meet on the other side, and that's going to make a cone. So that's what our cone looks like. Okay. So nets of solids is, cutting it, laying it open, flattening it out. And then if you folded it back together, what would it look like? Here's some more. Okay. So if I look at the shape and then determine what it is. So let's look at this first one down here. This would be a cylinder, right? Fold the circles up, wrap the rectangle around. You're going to make a cylinder. None of these up here are cylinders. Okay, number two, if we were to fold on these three lines, fold these triangles up, they would all meet on their edges and meet at one point here at the top, and that's going to be a triangular prism. The base is a triangle, the sides are triangles. That's a triangular prism. Number three, we just saw this one. So if we fold these triangles on these edges and bring them up and then fold our rectangles along those edges and put it all back together, it's going to look like this triangular prism. And then four, you're getting a unique look at a cube here. Notice that all of these squares are exactly the same. And if I fold them, wrap it all together, it's going to make a perfect cube, which is made up of 6 squares, the exact same size. Okay, so that's looking at some nets, and that's just identify them. Now what we can do is kind of take a net, put it together, and talk about some of the characteristics of it. So what we're saying here, the faces of these nets are labeled A, B, C, D, E, and F. When we fold this solid back together, which pairs of faces would be parallel? So parallel would mean they would be across from each other. Okay. So would E and F, if we folded this back together, making a cube here, would E and F be parallel to one another? Answer is yes. They wouldn't share any side in common, E and F. They would be opposite of each other. B and D, if we folded it and put it together, if we wrapped it up, D would be parallel to B. So yeah, those two are parallel. A and D. Now, if we folded this together, D would kind of wrap over and share an edge with A. So that's not parallel. A and C, you can see these two, when I fold A up and fold C up, these two aren't going to share any edges and they're going to be parallel to each other. Now down here it says choose all the figures below that show the solid formed by the net. So when you're looking at this, you're looking at, I'm looking at B, C, and F and saying, should these guys all be sharing an edge like this? So if I go up here, if I think about folding along this line and bringing C up and folding F up, then F, C, and B are all going to share an edge, and this shape could look like this. Okay, down here, A, E, and C. So A, E, and C. Are A, E, and C going to form this type of a shape? Well, I don't think so, right? A, E, and C are not going to look like that. Okay, so that doesn't work. A, C, and B. A, B, and C. A and C are going to be parallel to each other. This shows they're not parallel. Okay, so that ain't going to work. B, E, and C. B, E, and C. Yeah, if you folded them up, E and C are going to share an edge. B and C, E and B, they all share edges. I think that one's going to work as well. All right. So another one like this, A, B, C, D. So it's the same. It's the same. Net concept, but they've moved the E over to here. Okay. So when we fold this into a solid, which sides are parallel? If they share an edge, they're not parallel. A and C do not share an edge, so those two will be parallel. E and F, okay, do those two, will they share an edge when you fold this thing together? Well, you got to kind of think about folding this side up and E over and F up, and I do believe E and F are not going to share an edge, and they are going to be parallel. A and F, when you fold F up and A up, they're going to share an edge. So they are not parallel. B and D, they do not share an edge. When you fold this up, they are going to be parallel. Okay, choose all figures that would be representations of the solid when we put it together. So E, C, or C, E, and D. C, E, and D. Right, we could fold D up, we could fold E up. E and D would share an edge. C and D would share an edge. C and E would share an edge. That's a good one. B, E, and C. B, E, and C. Okay, so if you fold C up and E down, EB share this edge, BC share an edge, EC share an edge. That's a good one. BDC. So BDC. Well, B and D should be parallel to each other. And if they're parallel, then they can't look like this. So that's no good. And then A, E, and C. So A, E, and C. Okay. Will it look like this? A, E, C. I don't think they don't, oh, A and C are parallel, right? So they're across from each other. So they can't share an edge. So that's no good. So these are the only two that work. Okay. All right, this says use a net to find surface area. So this is where it can be really helpful to talk about nets and understand what they look like. If you were to take this rectangular prism and cut it along its edges and flatten it out, it would look like this. Okay, this is what it would be. So remember, we always talked about the fact that this rectangle and this rectangle are across from each other. They're the same. This skinny rectangle and this skinny one are the same, and then the bigger ones are the same. Now, if I superimpose my numbers over here, okay, this edge is 5, so that's that edge, 5. So this would be 5, and this would be 5, and this would be 5. And also this would be 5. If I was to fold it up on top, this 5 and this 5 would match these. So those are all 5s. Okay, these are all the 10s. 10, 10, 10, 10, 10. That's the distance across all the way. And then these little cutouts right here are 2s. So if I project my numbers onto this, I get a shape that kind of looks like this with labels. So I use this to answer the first question. How A is represented by what? Well, that should be 5 feet. B, where's B at? B's down here. So B would be 10. C is here. That's 2. And D is here. That's 10 again. All right. Now, this is where it's interesting. It says use the net to find the surface area. So if I use the net to find the surface area, what I would do is say, okay, these two rectangles are 2 by 10. They're the same, so I'm going to double 10 times 2. These two rectangles are 5 by 10. So I'm going to take 5 times 10 and double it. These two rectangles on the side are 2 times 5. I'm going to double that. Now that accounts for all 6 faces real quick here. So if I do the math, 2 times 10, 20, times 2 is 40. 5 times 10 is 50, times 2 is 100. 5 times 2 is 10, times 2 is 20. Add them up. This surface area is 160 feet squared. That may give you a better visual as to how we do surface area. Okay, pretty straightforward though. Another one, but now it's a little different because now we got a triangular prism. So we got a triangle here and a triangle there, exactly the same. If you were to make a net of it and flatten it out, cut along all the edges and kind of force it flat, this is what it would look like. 3 rectangles, 2 triangles. Now let's put some numbers into it. So these 7s are the distance across. So 7, 7, 7, 7 right there. Okay. These are 5. See this hypotenuse here, this side across from right angle is 5. That's 5. And then this rectangle and this triangle are going to meet at this edge. So those are 5s. Okay. These two inside sides are 4. And then this is 3 and this edge is 3. Again, when we fold it back together, this 3 distance, which is here on the triangle, and that 3 are going to match up. All right. So I use this to answer questions. A would be a length of, right down here, 7. B is the 3. C is 4. And the D is 5. And now use the net to find surface area. So I'm going to do it like I did the last one here, right? First, I'll find the triangles. Here's my 2 triangles. They both have a base of 3 and a height of 4. So 1/2 base times height and double it because I got 2 of them. And then start doing rectangles. This rectangle is 3 by 7. This rectangle is 4 by 7. This rectangle is 5 by 7. There's my 3 rectangles, my 2 triangles. That's all the surfaces here. So do the math, add them up, 96 square feet here. Okay. Okay, again, using nets, they're asking us here, here's a square pyramid, which means the base is a square. The sides here are all triangles. And here's the net. Here's the square. And then here are the 4 triangles that stem off of that. All right, we're supposed to find the area of the base of the pyramid. Well, the base, they told us, is a square. 6 times 6 is 36. So the area of the base, which is the shaded square here, is 36. Find the area of one lateral face. So they're calling this, the sides that aren't the bases are the lateral faces. So they're saying find the area of one of the triangles. Well, remember this was a square, so it's 6, 6, 6, 6 all the way down. So, or across here. So 6 is so we do 1/2 base times height. 6 is the base, 5.1 is the height. You can see it right here in the triangle. We're going to find the area here, and that's 15.3 yards squared. Next one says use the net to find the lateral surface area. Okay, the lateral surface area is when you find the surface area but don't include the bases. All right, so the lateral surface area is going to be these 4 triangles. Well, I know the area of one of them is 15.3. So if I take that times 4, I get 61.2 yards squared. That's the lateral surface area. That's the four triangles together. And then the last question says use the net to find the total surface area. So the total surface area, guys, we should know is the square base, 36, plus the four sides, which we already totaled up to be 61.2. It's going to be 97.2 yards squared. So that's using a net with a pyramid. All right, one more here. So now we change the pyramid up. We got a triangular pyramid, and this is the net for this triangular pyramid. It says the lateral faces are congruent triangles, so all the triangles are the same. The base is an equilateral triangle. Now, equilateral means all sides are the same length. Okay, so question number one, find the area of the base. So we're just looking at the blue triangle here. Remember, it said it's equilateral, so that's 9, that's 9, that's 9, all the way around. So the base is 9, the height is 7.8. How do we find area of a triangle? 1/2 base times height. 1/2 9 times 7.8, 35.1 yards. Okay. Next, find the area of one of the lateral faces. So again, the lateral faces are the triangles. These are the triangles that make up the sides, if you will, of the pyramid. So we said all the side lengths for the triangle, because it's equilateral, on 9. So now we're looking at a base of 9 and a height of 8. So again, area of a triangle, 1/2 base times height, 1/2 9 times 8, 36 yards squared. So this triangle has an area of 36 yards squared. Now, use the net to find the lateral surface area. The lateral surface area is all of the surfaces except for the base. So I got, oops, this should be a 3, guys. My apologies. I got 3 triangles. Each are 36. So this should be 108. I screwed that up. 108. That's my mistake. Make sure you fix that. 3 of them, 108. And then finally, last question, find total surface area. It should be my triangle base plus my 3 sides. Remember, that should have been 108. That's my mistake. And add them all up. That's not the right answer, but we just talked about that. So 108 here, add 108 and 35. That should be your total surface area. So that's how we can look at a net and help ourselves out a little bit. Okay, that's the end of this lesson. So please, after you're done with this, hopefully you've written down some notes, have some ideas. The homework's on Alex. Okay, have work to support your answers. You know that we need to see that. And well, I'll let you have at it.